When I say order O2 equal to O1 dot clone, okay, when I say order O2 equal to, for O1 there are some details like order ID 1001, order ID and product. For the product, this is separate object, right? For the product, this is separate object. Okay, this is like, let us say it is storing the values of this one, this thing. It is like it is separate object. The separate object is not created here. It is just pointing to this object. It is just referring to this product object. Okay, here that will be the memory address something. Memory address, let us say the memory address is 5000. Okay, so 5000 value is there. It is referring to this memory location, right? Okay, for order O2 equal to O1 dot clone, if we say whenever we see this statement, then for order O2, new object, new memory will be created, and the values of the instance variable does bit by bit copy. So here 1001 will come, and here the 5000 will come. This both orders O2, O1 and O2 are referring to the same product, O5000. If I change the details of product using O1 or O2, right, using either one of them, the details of the product will be changed in O2 also. If I change O1 dot product, how to get product dot name something, get product name or update product name. Let us say if we are updating the name of the product from using O1 to some other product name, for O2 also product name will be updated. Because what is happening here, this object is referring to some memory location. Only this memory location we are storing in O1. Okay, while copying, what happens, it does bit by bit copy, right? 1001 will copied here, 5000 will be copied here. That means it is the memory location of this product. So both of them will be pointing to the same product, referring to the same product. If one of the product details of one of them is changed, the other product details also will be changed. Okay, this is happening because the object class clone method does shallow copying. We are just, how we have written the clone method in the order class, we have just mentioned it as return super dot clone, and we are just typecasting it to order while returning that. So it does bit by bit copying. Okay, if we have if we have any objects as instance variable in our class, then we should clone that object also in our code. Yeah, I will show that example also how to do that in order to avoid this. Okay, here you can see both of them. Here the order class clone method is defined such way that it calls only the superclass clone method, and just we are doing the typecasting it as we have mentioned it. The clone method of the order class returns order here, that's why it is typecasted to order. And just, yeah, and yeah, that's why here it does shallow copying. If you see here, od1 dot update order of 101, like 010, we are making the order id, we are changing the order id. If we change here, if I change the order id here to 1010, later, later I am changing, will this O2 order id will change? No, right? Because for O2 order id is 1001, but we are updating only O1. So it is both are pointing to the different memory location, so only O1 order id will be changed, as it is not object. Here order id is not object. Order id is just some string. Is it string? No, it is int. It is primitive, no problem. It is not object. Okay, that's why order id for od1 will be 101010, and for the for O2 will be the initial value 1001. Okay, and we are updating the product name to pencil and price to 20. So both the product's name, both the product details will be updated now. If I run this, you will see for od1 and for od2, the only the product id will be different, but product details, see product id, it's for od1 it's 1010, and the product name is pencil 20, and for od2 order id is like as its initial value. It has not got updated, but product name and price of the product has got updated. This is because we have object as instance variable here in the order. The product is object and that is present as instance variable in the class order. So when we update the product details of any order, the other one also will be affected because we are doing shallow cloning in the clone method. So in order to avoid that, what we should do, we should define the clone method in the product class. And here you can see now the class product does not have any clone method. Yeah, the class product does not have any clone method. Right here, product does not have any clone method. In order to avoid this kind of shallow copy, we have to define the clone method in we have to define the clone method in the class product also. Okay, public. So product only I'm saying, return type is product. And in order to do that, your class must, in order to override the clone method, your class must implement the clonable interface. Clonable interface class product. Return type is product, and method is clone that throws clone not supported exception. Okay, here are there any objects in the class product as instance variable? No, right? They are just strings are immutable, even though they are object. Whenever you create a string, you will get new string, new string. Okay, it's and double these are primitive data types, no, not an object. So we can simply say return. So like product, we have to typecast it. Product super dot clone. So we're just calling the superclass clone method, that is object class clone method, and we are just typecasting it. The return type of the object class clone method is object. We're just typecasting it to product. Okay, now in the
Can you
order
explain
class clone method,
super dot clone? What
sorry,
it what it does na super dot clone and product
super
also.
dot clone is a, we are calling the object class clone method that just that does the bitwise copying of the of your instance variables. Bitwise copying. Okay, bitwise copy means the values of the instance variable will be copied from one object to the other object. Okay. Now, what I will say here, order O1 equal to order of super dot clone, like super dot clone method I'm calling. That's a
Madam, this is order. No, why order over? Wow, okay. We have to
so
change.
yeah, we have to update O1 dot
Okay,
product.
this over.
Yeah, O1 dot product equal to what I can say. I can call the clone method of product. I can say O1 dot product dot clone of. That means it will create the new product, right? It will create the product and that will be assigned to O1 dot product. Okay, new product. The values will be copied, return O1. If I do that, if I do this, so now you can see our order details. O1 details has got order ID has updated to 1010 pencil 20. Product details also has updated to pencil 20. But for O2 everything is same. It has the values like 1001 pen and 15. That is the values with which we have created the object. See this one. O2 equal to OOD1 dot clone. For OOD1 dot clone means it has the values of order ID 1001, product name as pen, and 15 as its price. But O1 only we are updating. OD1 order 1 only we are updating. To order ID we have changed. The details of that product also we have changed. Okay, here in the clone method, what we have done in order to do the deep copying, we have created first cloned object of order. Okay, that's what order O1 equal to order super. We have called the superclass clone method and just typecasted it to order and the set assigned it to some order. So what is happened here? We have created the cloned object of order. For that cloned object, the product. For the product, what we have done, we have created other cloned object of the product for that cloned object and return that. Okay, the some people see, some people doesn't use clone method at all. Like in what, in OPP exam, some people just doesn't use the clone method and they does that in some other way. Yeah, they just create the new object of order. Yeah, I'm not sure how they do, but they does that without using the clone method. But this is how we do the proper cloning. Okay, first we will create the cloned object of order, and in that cloned object for the product, we will clone that product also. We will clone that product also. What it has shown us, deep copying solve the problems. So in order to do the deep copying, we have to recursively clone the nested object. So object in a object, we have no product, we have in order, right? That product also we have to clone that. So if we have any object as instance variable, then that object also has to be cloned recursively. So for that order, for the cloned order, the product also has to be cloned. Okay, if we clone that, what happens? New memory will be allocated. If we clone this, if we clone, we are cloning this, we are cloning the product also. That means new product will be created and the new product will be assigned to this value. Okay, that's all.
So if we have many objects, then so many times you have to do the cloning also in
Yes,
the
yeah, yeah, we have to do
recursively we have to do. And if the product is having some other object, then first while doing in the project product clone, what do you call um, defining the clone.
Mm.
There also you should have it like new product equal to product clone dot clone. Then we have to again whatever it is having, that also we have to change.
Yeah, yes.
Recursively, you have to keep doing it until you don't get any object
Object as
in
instance
the
variable.
instance
Yeah,
variable.
yeah,
Okay.
yeah. You can just solve first and third question. Second question we have already solved. First and third question of your practice assignment. Okay, just I will use some time just to solve it by yourself. If you have any doubt, please ask. Okay, that are like from cloning only. Just to solve.
But
First,
it is why it is better than like deep copy. Uh, just say that due to inheritance, cloning overcome the problem when there is inheritance, right? When we take inheritance of that class that we are cloning, right? If it is inherited from someone else or some class is inherited from it, right? Then it how it create problems.
yeah, it will create problem. So yeah, let us take the manager and employee case. It is loading. Mm. This one. Okay. What if manager extends employee? Right? Manager extends employee. Now for the manager, it has some promo date as its instance variable. Okay. Manager inherits deep copy clone from employee. So manager will inherit the clone method from employee. However, employee clone does not know that it, it has to deep copy promo date also. So if we have that thing, if the manager inherits employee, then for the manager clone method is available, but the clone method of the employee does not clone the promotion date, the new instance variable of that, so it does not create the copy for manager. Okay.
Okay.
Yeah. However, employee clone does not know that it has to deep copy promo date. Cloning is subtle, so Java puts in some restrictions. So because of this only this kind of things will happen. Java puts some kind of restriction. So to allow that to be used, a class must implement clonable interface. Not to use a clone method for a class, we have to implement the clonable interface and must override the clone method. Okay, m1.clone we cannot say because for the manager also has to implement the clonable interface and it should override the clone method even though it is available to the employee. Okay, understood now. So because of the inheritance, if the class inherits other class, then the clone method will be available. If the manager inherits employee, clone method of the employee will be available to manager, right? Clone method will be available to manager also. But in the in the employee clone method, the new instance variable of the manager won't be cloned. That kind of things will happen, right? That kind of things will happen. So in order to overcome only some restrictions are there, like if we have to use the clone method on an object, the class must override implement the clonable interface and must override the clone method. Okay.
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 So the parent class has to override the clone method, right?
Whatever the class, if I say e1 dot, if I wanted to use m1 dot clone, then in the manager should be clonable. Manager should implement the clone interface, clonable interface, and it should override the clone method.
Okay. 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 Yes. It should like when then we also have to override in the manager also, because in if we override in the employee, right, then how it will take care of that other instance variable that defined in manager.
Okay, wait, let me show you. It's lengthy code. Okay, now you have seen here person has name and address. Address is another class. In the address class also clone method is defined, and while cloning also we have created new person. We have created clone the person, and then for that new person address we are doing the address or clone, that we are doing the idea dot clone, and then returning the new person. Okay. Okay, that means we are cloning that also, address also. Okay, what if we have employee, class employee extends person.
Yes.
Okay, just will see whether I will be able to use clone method or not. For but we should
Employer dot
define
salary.
the constructor to give all the details.
We should define another variable, salary.
Ah, no need to define anything. Just see. Let us see the clone method will work or not. But we should define a constructor because we have to initialize the instance variable. That should be done. Public employee. So it takes some string yes, comma new person. Okay, string not new. It takes some new person of.
We should also take another instance variable that is not defined in person. No?
Okay, let us see. Let us see. Actually, clone method will work or not. Clone. If I say just clone, whether that clone will work or not. Super of even. Okay, just I have defined a constructor. Employee equal to new employee of. So it takes some person object. Person one per one, and for employee e2 equal to even dot clone. Can I say or not? Let us see. Clone method we have not defined for employee. It is there for person, but through inheritance will we be able to do that or not? See here. Constructor in the person class cannot be applied. Okay. Okay, you can see here also. Incompatible types person cannot be converted to employee. Even not clone, if I say here, that is also giving error. Just deal with this. Okay, just we'll see first this error. I will show. You should take some string name n comma address ad, and I will say super of n comma ad. I will say now no problem. While creating employee also I should give name. Okay, now let us execute. So you can see error at line number 68. Line number 68, we are calling the employee to equal to even dot clone. Incompatible types. Person cannot be converted to employee. So even dot clone is returning person, but we are cloning it to employee. That is not permitted. Okay, let us do this as object. Do this as object here, and here typecast it. So yeah, by return type is object, but I can assign it to. See, this also won't be possible. No, employee to equal to new. See, incompatible side. Now also person cannot be converted to employee because person, the return type is person. If you have not defined the clone method in employee, you have to define clone method in employee. Even though there is instance variables, even though if you don't have anything, you have to do implement the clone method in order to use that. You are not clone, I can say, but the return type is person.
Okay.
Okay, if you have to use a clone method in any class, your class must implement the clonable interface and should override the clone method. Okay. Now, even though the person class, even if the class
That's implement.
is super class and employee is subclass, the clone method should be available for employee. But because of this, the return type and everything, unable to use that also properly. Yeah, right. So
It's
your
for that.
class, the
For,
child class.
yeah. For using that, okay. We have to implement the clonable, right? That is it?
Yeah, if you have to use a clone method, you have to implement the clonable interface and just override the method clone.
But is it not implementing? The address is implementing. Uh, person is not implementing clonable.
Person is implementing clonable interface.
Uh, okay. Mhm. Okay. So we also have to put in employee,
Sorry,
like for clone method to work. What we have to do? Uh,
we have to define the clone method for employee also. We should make employee implements clonable, and
okay.
we have to define the clone method for employee also. Clonable, and here you can say public uh, employee clone or object clone. You can do here employee clone cross clone not supported exception.
Hmm, okay.
Return, you can say return employee super dot clone. Nothing to do here because we don't have anything. Just we are calling the super class clone method and just
Hmm,
doing the typecasting. Now it will work.
okay.
So now you have seen no error and now your code has worked. So in order to use the clone method, your class has to implement the clonable interface and has to override the clone method. Okay.
Whether or not it is extending or not, right? Because like we say, we see that if there is subclass, that is, if some method is present in the parent class, that is also available to the child class, but that is using dynamic dispatching, right? But
Mm.
in clone method it is not available, right? Dynamic dispatching.
The clone method is available, but the thing is return type of the clone method is some object, no? Return type of the some clone method is some object. Even if you return, see, because of the problem is because of the return type. Okay, even dot clone I say previously the person class clone method will be called, but the return type is object, and if you typecast that to like employee, that won't work because actually the we are that should be returned to person only, right?
Okay, okay. So every, if it implements like clone a method, it will only for that particular class. It will not take any other class and call that clone method, right?
Yeah,
Using dynamic dispatching also,
it
right?
does dynamic dispatching, but the
Mhm.
thing is it does not work like in order to, because we are creating the object employee to equal to new person, we cannot say because employee is super and person is employee is child class, person is parent class. So that kind of assignment we cannot do. That's why it won't work.
Okay, we are doing new person. If we do, okay, if we say new person per PER1 equals to new employee something else, then it will work. Something like that. Yes, ma'am.
Sorry.
But if we say person like using dynamic dispatching, na person per one equals to new person, sorry, new employee, then we can call to that PER1 called clone method, right? Uh,
Mm,
yes, right.
yeah.
Okay.
Okay, but the thing is, using inheritance, you have to be careful that does not work. You have to write the clone method separately. Okay, that's all. That's all regarding the 8.1. It's all about the cloning only. Next, we'll go to the next lecture. So, whatever you have seen till now, like if we are going to use a variable, then the type of the variable should be declared in advance. But you can, the Java does some type inference also. Okay, so type declaration versus type inference. So Java insists that all variables are declared in advance with type information. The compiler can check whether the program is well typed. An alternative approach is to do type inference. Derive type information from the context. For example, S should be string here because S equal to hello plus some word you are doing. So it is string concatenation you are doing. So S must be a string. Propagate type information. Note that T is also a string. T equal to S plus 5. So S is a string. We are doing string concatenation. So T must be a string. So Java allows this type inference also. In order to do that, I will see in the later slide how we does that. Assume code is well typed. Well typed. Derive most general types. Okay. Hmm. Java allows limited type inference only for local variables in functions. Only for the local variables in functions, you can use the type inference, not for the instance variable of the class. Okay, use generic var to declare variables. So instead of telling int x into y or float x or string s something like that, you can say var a, var s, var b, something like that, and you must initialize it to some value. Okay, in order to do the type inference, that is permitted only to the local variables of a functions. The instance variables cannot, for the instance variables you cannot do. Only for the local variables in the function you can do type inference by saying var b equal to false. That means by seeing the value with which it has initialized, the b is like boolean data type, and hello world is nothing but a string. So s is string. The 2.0 is a double, so d variable is double here. And f is 3.14 f, so f we have seen that is float here, where e equal to new manager. So what it's this data type, it should be a manager. So it does type inference for the variables, local variables of a function. In order to do the type inference, we have to use a variable var, generic var to declare variables, and must be initialized when declared. That variables must be initialized. We should initialize them. Type is inferred from the initial value. Be careful about the format for numeric constants. Okay, like if you wanted it to be double, then just don't give anything. But if you wanted it to be float, then f should be mentioned at the end, then only f type will be inferred as float. For classes, infer the most constraint type. E is inferred to be manager. Manager extends employee. If e should be employee, then you should declare employee assets explicitly. Where equal to new manager, here e will become manager only. Data type of the e will be manager only, it cannot be employee. If you wanted it to be employee, then we have to say var equal to new employee to infer the type. Okay, this is very simple topic. Okay, is it clear or not?
Yes, ma'am. Clear, ma'am. But sorry, problem I have, like when should we use a float or a double? Like for notation wise, it's clear, right? When we use f, it is float, right, and double
Hmm.
without f. But what's the real difference between them?
The real difference is precision. Float can store some precision, whereas double can stores to the largest precision, like precision after the decimal point. After the decimal points, a float precision is about, yeah, just I have to check on that, how what is the precision of that. Just see, just it is some bytes, like. So you can see the difference between float and double. So here you can see it is like float and double are both used to store the numbers with decimal points in program. The key difference is the precision and the storage size. A float is typically 32-bit number with precision of about 7 decimal digits, while double is 64-bit number with precision of about 15 decimal digits. So you can store after the decimal point, you can store about 7 decimal digits in case of float, whereas for the double you can store up to 15 decimal digits. Thus double can store larger numbers and provide more accurate calculations than float. Okay, that's all.
Okay.
It's byte size. It has 7 decimal precision, but it has 15 decimal precision based on the value which you have to store. Yeah, if you wanted to store, like let us say this one, it is less costly in terms of memory use. Yeah, just because of the memory only. Okay, that's all. Just after the decimal point, it can store only 7, whereas double can store more than that. 1, 2, 3, 4, 5, 6, 7 only. You have 7. But double, for double, it can store more than that. It can store up to 15 decimals. Okay,
Okay.
is it clear now? If you
Yes.
based on the value you want to store, you can go for either double or either float. Okay, just that's
Okay.
it.
Please.
Okay, automatic type inference can avoid redundancy in declaration. So a manager m equal to new manager. Here manager is coming twice. No, this kind of redundancy we can avoid by just by saying where m equal to new manager. Assume that the program is type safe. Derive most general type compatible with the code. Okay, like most general type. If it is where m equal to new manager, then m is of type manager. It won't be of type employee. Compiler can infer the type from the expressions used to assign the values. So based on the initial value or based on the expressions which we give at the time of initialization, at the time of declaration, initialization, compiler will infer the type of the variable. Infer type information can be propagated. So in the previous example, here t equal to s plus 5. So s type is string and we are doing s plus 5. So t must be a string. So that can be propagated. Challenge is to do this statically at compile time. So type must be inferred at compile time. So Java allows limited type inference, only local variables that are initialized when they are declared. So for the local variables in the function, type inference is done and the variables must be initialized at the time of declaration only. Only then the compiler can do the type inference statically, right? Okay, this is like lecture 8.2. Lecture 8.2 is about type inference only. That is very easy lecture. And functional interfaces. What are function? This is 8.3. The functional interfaces are from 8.3. What are functional interface? Interface that define a single function are called functional interface. Like comparator, timer owner, these are called functional interfaces because they have only single abstract method in it. The interfaces which has a single abstract function in it is called functional interface. Examples are comparator. In the comparator class, there is compare method. This is a functional interface because it has only one abstract method. How can we directly pass the So actually 8.3 is about higher order functions. Higher order functions means passing a function as an argument to other function is called higher order function. Okay, passing a function as an argument to other function. So you can see in the case of Python, we can say here, in the case of Python, We can see here list of map. Why it is going? Map itself is a method. In the map you are passing another method. To the map you are passing another method, square comma range of 10, both are methods. So for the function you are passing a function as an argument. A function takes another function as an argument. These are called higher order functions. This is possible, this is in the case of Python you are passing just as you pass variables. Similarly, like if you invoke a method, how we do, you will pass to add of x comma y, you will pass the same way, no, like you are for the for the functions also, for the functions also you are passing the same way only. Map of square comma a range of 100, you are passing them similar to the variables only. You are passing a function as argument similar to the variables in the case of Python. But how do we do this in Java? In Python, function names are similar to the variable names. So define a function, pass it as an argument to other function. Map is a higher order function. So map takes another function as an argument, so it is a higher order function. In the case of Java, how to do? So more okay, for this we have something called lambda expressions. Lambda expressions means unknown functions. Okay, unknown functions. So more complicated function you want, this is a continuation. Okay, here array sort method will take array and the comparator object. The comparator object, so comparator is like functional interface. If you have functional interface, then you can use lambda expressions. So instead of uh, defining a class and extending that implementing that comparative interface and defining the compare method, what you can do, you can just use the functional interface. Just I will open and it just let's, I think that is like more clear. So type inference you have seen, and here are the functions. So passing functions in the arrays dot sort, that arrays dot sort takes array and it takes some comparator object. Okay, comparator interface provides a signature for comparison. Just let me see. Here you can see this code. So this is comparator interface. In the comparator interface you have the method compare that compares the two object o1 and o2, and that is a generic interface, that's why it is defined as T. And string compare is a class that implements a comparator interface, and T is like string, you are doing string comparison. So in that compare method is overridden such a way that it takes two string object and return s1 dot length minus s2 dot length. It returns int. If s1 length is greater, it returns 1. If both lengths are equal, it returns 0. If s1 less is lesser than s2 length, then it returns minus 1. It does string comparison based on the length string compare method. In the array sort, how the array sort method works, it takes array and a comparator object. Here string compare is a comparator object that we are giving. Okay,
How it is returning s1 dot length minus s2 dot length, returning 1 or minus 1.
so
Can
s1 dot length computation, it will s1 dot length, it will give the length of the string, minus s2 dot length, it will give the length of the string. Both are integers. Integer subtraction will happen. That's all. Based on the value.
give, right?
Yeah, based on the length of the string, only the value of integer is decided. If both lengths are same, if the both lengths are same, you return a 0. If one length is greater than other length, then it returns the positive or the negative int value.
Integer value, not 1, right?
Hmm?
Sorry, not plus 1 or minus 1. It returns the difference between them.
Yeah, here it returns the difference between them. Yeah.
But if we
Okay.
want 1 or minus 1,
Yeah, you can say if s1 dot length greater than s2 dot length, return 1, else if s1 dot length equal to s2 dot length, then return 0, else return -1. You can do that. You can just what do
No,
explicitly.
there is not any function, sorry, library that we have in Python. Like we
No,
can get this signum function.
no. There might be there, but yeah, but like in order to use that, then you have to inherit or something you have to do, right?
Math library maybe.
So let us discuss about the lambda expressions first. Lambda expressions denote the anonymous function, that is this one. It has parameters and body. Return value and type are implicit. For the lambda expression denotes anonymous functions. They are functions. It has these parameters and body. What it does, return type and everything, and return value and type are implicit. Here the string s1 s2, this function for the comparator, this function you have compare function, no, in the compare function, whatever the like functional interface you have, no, comparator is a functional interface that has only one abstract method. If you have functional interfaces, you can define the compare method by using the lambda expressions instead of creating object and implementing that comparator interface and doing and then defining the method. You can just use this kind of lambda expressions if you have only if you have a functional interface. You can use lambda expression instead of inheriting and doing that, implementing the interface and doing that. Okay, here lambda expression denotes anonymous function, that means it does not have name, and like parameters we will provide in the brackets followed by the arrow mark, and then the body of the method will be there. The return type and return value are implicit. Okay, so this can be this functional, we can substitute with the lambda expression wherever the functional interface is there. So here arrays dot sort method will take an array and a comparator object. So comparator object, instead of giving the comparator object, you can just give the definition of the compare, whatever that abstract method you have in that interface, you can give directly. Okay, so if you have more complicated functional body, you can do this like this. In the brackets, you will mention the parameters followed by the arrow mark. Then you can open this flower brackets and define the function body. If length is greater, less, return -1, return 1, return 0, LC. Yeah, this thing you can do in this explicit like this you can do. Here also you are not mentioning about the return type. Note the function is anonymous only for the caller. Only for the caller it is anonymous. Okay. Here you can see we have here how we have done, we have passed a function as an argument to other function. For the sort method, we have passed this function. Okay, this function. The function that receives a lambda expression still needs to use a functional interface for the parameter type. So function that receives the lambda expression, this is the function. Sort function is the function that is receiving a lambda expression that should use the functional interface. That should use the functional interface for the parameter type. It is using the comparator interface for the parameter type. So for whatever the method you are giving the lambda expression, that function must be defined, must take, that function will take a functional interface for the parameter type. Sort method, for the sort method you have given previously, we have given that here you can see we have given if a lambda expression. So the sort method is defined such that it takes a functional interface as its parameter. Here comparator is a functional interface. Okay, the function that receives the lambda expression still needs to use a functional interface for the parameter. Okay, passing the named functions. What now you have passed lambda expressions, right? If the lambda expression consists of single functional call, we can pass that function by name. Method reference is called method reference. Okay, here scores dot merge of, here what we are doing in the scores is a map. We are merging that using two maps, bat and new score, and we have to do the summation of this. How do we should merge this both the scores map? By summation of these two integers, right? Then we can call, okay, whatever you have going to define here, whatever you are going to function body you are going to give here, that is already defined somewhere. Then you can use that by using the method reference. Here you can use the integer sum method. This is how can you use that integer colon sum. Here we have to sum these two values. We can this method sum method is defined in the integer. That's the same thing. Instead of defining it again it here, you can use the sum. It is defined somewhere, you can use that by just doing this kind of thing. Integer colon some notation you have to use. Okay, we saw the example with the adding the entries to a map. Here sum is a static method in the integer, so yeah, that's why you can use
We
it.
are invoking this method like this.
Hmm?
We are
Yeah, we are.
or
That means the function body will be replaced here. The function body of the integer sum. That means it takes like, instead of passing it as lambda expression, you can just call that method which is present, which is defined somewhere. Okay. Previously, in the case of Python, we have seen a map of square of square comma range. So
Hmm.
directly square method we are calling just by saying the square of something like that. Here you can do that in Java also. If the method is defined somewhere, whatever you have to define
Hmm.
as lambda expression, if it is defined somewhere in another class, you can just use that by using this integer
Okay, it
colon
is
sum.
static method also.
Yeah, integer is, yeah, it need not be static method, it can be normal method also. Okay, here just summation we want to do, but this kind of, in order to do this kind of comparison, you have to define the, we saw the example with adding the entries to a map. Here sum is a static method in the integer, here is the corresponding expression assuming the type inference. Okay, expression should call a function and nothing else. The expression cannot be replaced by the method reference. This one we cannot do by the method reference. For this we have to do first summation I plus j greater than 0. We have to check, we can, if we are just calling another method, if we wanted to do exactly the same thing that is defined in the other method, then we can do this kind of method reference. But if we do some kind of comparison or some operation other than the whatever that is there in the method, then we cannot do method reference. Then we have to define the method here, like define the lambda expression I comma j, then the arrow mark, then you will see if I like you can say return of I plus j greater than 0, but it will return either true or false. Okay. So method reference can be done by using this kind of notation: class name colon static method. Okay, corresponding, or else you can have class name colon instance method also. This kind of notation you can do if you wanted to refer to some method which is already defined as your lambda expression, then you can do the method reference. So object colon instance method, you can do this kind of notation also. Yeah, I will show with the examples, practice assignment exam. So type inference is very easy concept, but this method, this kind of thing is a bit difficult. Okay, let us see the practice assignment question number 5, that is based on the lambda expression only. We want this is, there is some class person, it has some class person has name age constructor and get age, that is the accessor method and print method. Okay, now you have main main method. In the main method, var list equal to new array list of person. So that is like var is nothing but array list of person. Type parameter is person. This is how we do the type inference. In order to do the type inference, we have to say var followed by the variable name list dot add of new person comma Robin comma 33, just we are adding the elements to the list. Collection dot sort of list comma, so you have to, you are sorting the list and sort. In order to sort, just to see how the sort method is defined in the collections, just to see that from the Java documentation I will show. Anyone, any idea how the sort method is defined in the collection, what parameter it takes?
It takes two parameters only.
In the
Hmm.
options only it is given, no, madam. Like one of the option minimum it will be.
Yeah, in
Uh,
the option it is given just to show you like what sort method of collections will take.
it will take both ages A and B.
Just give me a minute, just. Yeah, yes. Yeah, just yeah. Anyone, can you quickly see what sort method, what collections dot sort method is taking a list and something I think comparator only, right? Comparator it takes. So we have to compare the elements of the list. So comparator is nothing but a functional interface that has a compare to method. So compare to method takes two objects as its argument, right? So how that is done, you can see we are inserting them in some random order. Robin, Indra, Smita, Ricky. So yes, 76, you can see the integers are aligned, right? Integers are aligned in which order? In descending order, 76, 35, 33, 26. So we have to compare the two integers. If their age is greater, it should return a positive value. If a age is greater than b age, if like, it should return some positive value. If we are going to compare two persons based on their age, like two-person object, we have to compare, no? So it takes two arguments a b. So a and b are two persons, two-person object we have to compare based on their age. So we say a1 dot get minus b dot get age. Okay, or you can do this in this way also. But the sorting it does in the ascending order. Generally, the sort method,
Me as my it is taking two arguments. One is list and one is what method we want to apply. Whether we want to apply a minus b or b minus a. Like
yeah, whether we wanted to a minus b or b minus a. If I say a by, see, generally this does sort, it does ascending order sorting, okay, ascending order. But in order to do the descending order, we have to see b dot get age minus a dot get age. Okay, so it will return a positive. It will be plus 1 if it will be plus 1 if b age is greater than a age. Okay, so it should be a comma b, b dot get age minus a dot get age, or person. We can specify the person, the what the type of the arguments, like person a comma person b, b dot get age minus a dot get age. That, in that way also you can do, or
and
you
this
can
sort
say
is applying quick sort, right? So it is taking two argument and then checking it, right?
sorry.
Like this sort is quick sort, right? That predefined sort method.
It is
But it's
predefined sort.
comparing two arguments only at a time, right? So it need to take two arguments and convert. and convert it to A minus B or B minus A, whatever he
It
wants to
is descending order, no? That's why we are doing B minus. If it is ascending order,
do.
you can use A minus B. So generally sorting, this sorting is ascending, it is ascending order sorting. Okay, in order to do that descending order, we are just doing B dot get H minus A dot get H. So it returns, okay. Generally, uh, as it is ascending order sorting, if you have numbers like 10, 9, 4 and 12, if you wanted to do this ascending order like 4, 9, 10, 12, so we have to compare this value. Okay, we will compare first this value and this value. It returns plus 1 if this one is greater than this one. Okay, 10 minus 9 if we do, and what is the value it will return? It will return plus 1. So return means plus 1 means this value is greater than this value, right? So just we'll keep
10 as it is, right? We want to
we'll
do
keep 10 as it is,
like
and then 9 is in the second. Then we do compare these two, 9 and 4. So 4 will come, 9 will, yeah, 9 minus 9 is 4, 9 this order only, and 12 you have, but yeah, how this does sorting, but how, yeah, how it is done internally.
that's using quick sort map, but it actually take two functions. For one is comparing two argument and then merge into it, right?
Yeah,
Merge.
that,
No.
yeah, 10 first 10 comma 9 comparison will happen, then 10 comma 4, then 10 comma 12. Okay, based on that the upper value, the numbers will be aligned. So 10 minus 9 is 1, 10 minus 4 is also plus 1, 10 minus 12 is minus 1. So if it is minus 1, what
Then
happens?
it will
What
not change
happens?
10. Instead, it will change with 4 first. And in the next iteration, it will again compare. Uh, it will that if compare 12 is compared with anyone else, if it is minus, then it
Yeah,
again.
it doesn't matter for us, but just the sorting works. Some sorting it does. It
Hmm.
just arrange the numbers in ascending order. This collection dot sort. Just open the Java documentation and see how the ascending dot. So collection dot sort of list comma some comparator. So sorts a specified list according to the order induced by the specified comparator. So whatever the order, whatever the how we are defining this comparator method, based on that the comparator, that the elements will be arranged. All the elements in the list must be mutually comparable using the specified comparator. This is E1 dot compare of E2. E1 must throw class cast exception for element in the list for any element. The sort is guaranteed to be stable. Equal elements will not be reordered as a result of sort. Specified list must be modified but not resizable. Implementation of just import the comparator. So what it does, for the mathematically inclined, the relation that defines x comma y such that x dot compared x comma y less than or equal to 0, the quotient, yeah, what, how we are defining the compare method. Compares two arguments for order. Okay, compare method will compare these two arguments for order. Okay. So just I want to show you that the compare, it does ascending order sort. Just okay, the implement must ensure that the signum of compare of x comma y equal to minus signum of compare. This implies that compare of x comma y must throw exception if any, if and only if compare of x comma y throws exception. Implement. But okay, returns. This returns a negative integer 0 or positive integer as the first argument is less than. If the first argument is less than the second argument, if the first argument is less than or equal to or greater than the second, if it is first argument is less than the second one, it throws a negative integer 0 or positive integer. That's what we also discussed. No, the comparator method generally we will define such that it throws it should return minus 1 if the first value is less than second value. Okay, for 10 and 12, if we have 10 and 12, what will it will return? It will return minus 1 because 10 is less than 12. Okay, if then if it returns minus 1, we just this kind of interchange. So 12 will come first, 10 next. Okay, this kind of interchange will do. So what, here in the question, whether we have to do a minus b first or b minus a, that's the question, no, for you. B dot get h minus a dot get h, as they are in the descending order, as they are in the descending order, right? So if we should return a plus 1, if we should return plus 1 if when should we return plus 1? If the second value is greater than first value, or if the first value is greater than second value, when should we return that plus 1? Just I will show here that we have solutions. Just the confusion is this one only. Okay, option 1 lambda expression and option 3 lambda expression are syntactic clear. However, they sort the person object in ascending order, but how the sorting is done, it is not given. But the thing is, it does ascending order sorting. B dot get h minus a dot get h, option 4 the lambda expression. This does descending order sorting. Okay, yeah, just yeah,
It
just
says we have to define one compare to also, right? So it doesn't define here. So
yeah,
it is
compared to method is a lambda expression that we are giving a comma b and
it is
a.
returning if
Yeah, it's
define.
return type and everything are implicit. It's no need to mention that, they are not required to mention. Even if you mention, it's okay. This is the lambda expression, right? Lambda expression will have the arguments in the brackets. The return here return the data type of a and b are also implicit, and just the function body you have to mention after the arrow mark. Return statement can be included or can be, yeah,
Madam,
it's
for
not required.
collection dot sort in the sort function, what are the two arguments we have to give?
It is a list and some
One list
comparator object. So it as
comparator object.
comparator. Yeah, comparator is a functional interface. Instead of giving an object, you can give the lambda expression. That's what we have seen. The
Okay.
whatever the method that is taking a lambda expression as its argument, then its argument must be a functional interface, right? Here sort method takes a functional interface as its it takes a functional interface as its argument. If the argument is a functional interface, then you can substitute it with the lambda expression. So it takes the comparator object here. So instead of comparator object, you can give the lambda expression. You can give the definition of the abstract method which is there in the comparator interface. This is the definition of that abstract method compare. Okay. This is just the confusion, no confusion with the lambda expression, just sorting. In order to do the descending order, we just subtract b minus a. Um, okay, here 33, 76 we have. 76 should come first. So how to do? If I say 30, yeah, in order to just remember this for now, in the next class or something I will just search and tell you. In order to do the second descending order sort, we will do second argument minus first argument. If you want to do in the ascending, we will say a minus b, a dot get h minus b dot get h. Okay. Okay, are there any other example of this functional interface in this? Yeah, merge method also. For the merge method also, you have seen it takes two argument and merges and some method reference. You have seen how the merge method, maps dot merge method, what arguments it takes. Let us see. If it has some functional interface as argument, then you can use lambda expression. Right, so this is a map and you have merge. Concurrent hash, not a hash map. You have merge. It takes key value and some method, tree map dot merge. So it is, we are giving some lambda expression, that is method reference here. We are doing just the concatenation here. Here what the merge method takes, the specified key is not already associated with a value or is associated with a null, associates with the given non-null value optional value, otherwise replaces the associated value with the results of the given remapping function or the function. So it just takes some, it is just something, it merge method will take some remapping function and that is a lambda. You can give a lambda expression here, remapping function to recompute a value if present, key with which the resulting value has to be associated, value the non-null value to be merged with the existing value associated with the key, or if no existing value, the in or a null value is associated with the key to be okay, returns a new value associated with the specific key or null if no value is associated with the key. So just understand here, the merge method also takes two arguments, one is key and the other one is value, and the thing and the remapping function, a remapping function maps this key and value. Let us see here. Here you have map prices. It is a linked hash map. Just we are putting these elements in the map, pen, pencil, notebook, paper, and for each entry in the map, we are just merging the key value. The output should be like pen 33, pencil 11, notebook 44. So some function, remapping function we have to do. So here 33, how we are getting 33? You have get key, e dot get key, that will give the key, and comma 0.1 is the value, x comma y. So x comma y is the key, comma y is the 0.1. So x plus x into y, x into y. So it will be like something like 30 plus 30 into 0.1. So this is a remapping function. So you are just taking, this is a lambda expression of, just we are taking x comma y as an argument, x and y are nothing but e dot get key of. So e dot get key of first key is pen. So first key is pen and the value it is like 30. So 30 come 0.1 equal to the mapping function is x plus x into y. So it is mapping correctly or not, let us see. 30 plus 30 into 0.1, that is 0.3. So 33 you will get. Next is next if you say y comma x. So y is this one 30 and x is 0.1. So if you do this won't be the correct answer, no. The second the third option, if you do third option also not correct, right? The third option is also not correct, and the fourth option is correct because y is the first argument and x is the second argument. You are doing y plus x into y. So just see the remapping function, they are asking for the just the remapping function. We are doing that using the lambda expression, and the method, how the method, that remapping method should be defined, because just we are, whatever the existing value, we are multiplying it by zero point 0.1 and we are adding that to the existing value. So 30 plus 30 into zero point 0.1 we are doing. So first and the last options are correct. Okay, that's all about this higher order function. So if you have functional interface, instead of defining a class and implementing that interface, you can just substitute it with the lambda expression. Lambda expression nothing but you have arguments followed by the arrow and then the method body. So the arguments data type you can mention, or if you not mention also, it can, the compiler can interpret based on the arguments it get. Okay. Yeah, if you have any doubts, you can go through and ask me in the coming classes also about this lambda explain. These are a bit confusing because if you see them for the first time, it is very confusing. So next one is streams. So how will we iterate through the collection? We will just use some for loop to iterate through the collections. No, we use an iterator to process a collection. Suppose we have to split it. Okay, we use iterator to do this, you know, to iterate through the collections. But you can do that without iterating also. You can convert the collection to a string, and then you can just, we can convert this. Words is nothing but a list of strings. Okay, you are just iterating in this way. Instead of that, you can convert words to string and apply the methods like filter, count. These methods are there. These are, you can see, these are nothing but filter is takes a lambda expression. It has some functional interface as its argument. So we are giving the lambda expression. How it filters based on the length of the words. If the length of the words is greater than 10, then it will filter those, only those words, and count that words. After filtering, we'll get the count of those words. Okay, we usually use an iterator to process a collection. Suppose we have to split a list of words. We want to count the number of long words in the list. How we will do? We will do in this way. We will just iterate to the list of the words and check the length of each word, whether it is greater than 10, that means it is considered as a long word, and we are counting that. An iterator generates all elements from a collection as a sequence. Okay, it will generate all the elements from the collection as a sequence. An alternative approach is to generate a stream of values from a collection. We can generate a stream of values from a collections. Operations transform the input stream to output streams. So operations, whatever operation we do, that will transform the input stream to the output stream, terminate with a result. We can terminate it with a result. Okay, so why streams? Because stream processing is declarative. It is not like imperative. We know what we want. We will just mention what we want. We are not mentioning how to do. Okay, we'll just, here you can say filter. By filtering based on the length greater than 2, it will just filter. Okay. Okay, recall the declarative versus imperative. Focus on what to compute rather than how. Okay, that declarative will focus on what to compute rather than how to compute. Filter will filter the string, and count will count the number count will perform the count. So here the processing can be parallelized. Parallelized. Here you can see filter and count that will work in parallel. So words dot parallel stream you can do. If it is parallel stream, then the operations filter and count will happen parallelly. After filtering a element, the count value will be incremented. Okay, so both the actions are happening parallelly. Okay. Lazy evaluation is possible. This is declarative. The only thing is this is declarative. It is not imperative. You no need to focus on how to do. You just tell what to do and you will get the result. Lazy evaluation is possible. Suppose we want first 10 long words. Only first 10 long words. We can just stop generating the stream once we find the 10 such words. Okay, we can stop generating the words after finding the 10 words. Need not generate the entire stream in advance. Can even work in principle with inference stream. So you can stop generating here. Here, if you use parallel streams, you can stop generating after reaching some 10 such words. That are also possible. Check if count like count, and you can check with the count greater than 10, and then you can terminate it. So intermediate variables, everything is not required here. It is declarative. No, it's no need of some intermediate variables also. Okay, stream does not store its elements. Elements are stored in underlying collection or generated by a function on demand. Okay, going to store the elements. Stream operations are non-destructive. Input stream is untouched. Okay, input stream is untouched. The stream remains the same. Only the result after performing the operation, the input stream will be same. Okay, apply stream to a collection. You can just how to convert a list to a stream by just saying a word list dot stream. That will give the stream. That will give the stream. We can convert a collection to a stream by mentioning this word list dot stream. Okay, this will give the stream of string, and the name is given as word stream. Okay. So if you have arrays, how to convert them as a stream? Just to say stream of this method you have to use, stream of method you have to use, and that will convert arrays to stream. Here word array, ARR is a array, and you can convert it to stream by saying stream of. Instead of using iterator, you can just say you can iterate using the streams. Words dot stream of, that means it will give the stream of the words, and you can just filter them, map them to some other function, or do some operation based on our requirement. Instead of using an iterator, you can do some lazy evaluation. So you can generate the stream of numbers also. Just say stream dot generate, and the method how to generate we have to give. So here stream dot generate, here there is lambda expression. How actually stream dot generate method takes another method to generate the stream. So here instead of giving a method, we have given the lambda expression that will generate echo, stream of echoes. Okay, here stream dot generate of math colon random, here that will give the stream of random numbers of doubles. Okay. Okay, static method stream dot generate generates a stream from a function. It generates a stream from the function which we pass here. Provide a function that produces values on demand with no argument. Without any argument, we are providing on demand. We are generating the numbers. So stream dot iterate a stream of dependent values. In order to generate the stream of dependent values, we can give the stream dot iterate that will generate the stream of dependent values. Here 0 comma n colon n arrow n plus 1. That means the first element will be 0, the second element will be 1, third element will be 3, fourth element will be 4, something n plus 1. So it will generate initial value. In order for the stream dot iterate method, it will generate a stream of dependent value. That means the first element is dependent on second element will be dependent on the first, and third element will be dependent on the second, like that. Initial value will give the initial value, and the function to generate the next value from the previous one we will mention in the stream dot iterate method. Terminate using a predicate. You can terminate that using a predicate. You can say you if you want stream of 100 numbers, and the each value should be like plus one of it. So first number is 0, second number will be 1, the third number will be 2, and n value is less than 100, so it will generate the stream of 99 numbers, 0, 1, 2, so on to 99. So this is how you can generate the stream of numbers. Stream dot generate you can use and pass a method as its argument. It will generate the stream of random numbers. But if you want the stream of dependent numbers, you can use stream dot iterate, and the initial value, some lambda initial value, and the condition you can mention, and the how to increment, how to get the next value. The filter method is just to filter the elements of the string. Filter method takes a predicate, takes some method. Predicate means some filtering method to filter out. Here the example is we are giving a method to filter out the long words. Okay, stream of string, you are converting word list to string, that is nothing but a stream of string. For that stream you are filtering the words based on the length. Actually each element of a stream is a string. You are checking, that is w, that is an lambda expression w, and you are checking the length, whether length of that element is greater than 10. If it is greater than 10, only that elements will be filtered in the long words. Map, this is filter method that will filter out based on the predicate we give. Map method applies a function to each element in the string. So the map method will applies the method to each element in the string. If you say, if the elements are integers, if you say dot map, okay, you have the stream of integers. If you say dot map stream of 10 integers, if you say dot map of some I into 2, if you say, then every value of that stream will be multiplied by 2. So map method will apply whatever the method you are giving, that method to each and every element of the stream. So map applies the function to each element in the stream. So map method takes another method as its argument. So that here you are giving it as lambda expression s arrow s dot substring of 0 comma 1. So we are extracting the substring. So it contains only two elements, first two elements. Extracts the first two letters of each long word we are doing. The map method does applies the method whatever we are giving in the argument to each and every element. Okay. Whereas filter outs based on the condition. What if map function generates a list? If it generates a, suppose we have this is not required. Okay, explode, this is, these are just assumptions. Okay, explode of s that returns a list of letters in s. Map produces a string with nested. Yeah, this is not that required. This is just, so flat map flattens or collapses the nested list into a single string. If you are, if you have nested list, then that flat map it will convert it into single list. Yeah, this flat map, these things are not that important. Okay. So map dot stream, make a stream of finite numbers. You can limit that also. Stream dot generate will generate infinite stream. Now you can limit it to some numbers by saying applying the method dot limit of 100. So you are just, this is all, this is declarative programming. You are not specifying anything explicitly. Just you are saying limit. Then only first 100 numbers are getting selected from the string. Okay, skip of n. Skip of n, discard the first 10 random numbers. If you say skip of 10, it will skip the first numbers of the string. Stream dot generate will generate some stream of random numbers, and with whatever method we provide, based on that method it will generate the stream. And if you say skip 10, the first 10 elements will be skipped. And these are just the methods. These are the methods. Just you need to understand what method does, and just remember also filter does filtering. Map applies a method to each and every element. Limit will limit the elements to 100, and skip will skip the first 10 elements. So yeah, you have to remember that what they do also. Okay, take while stop when an element matches a criteria. It will stream will stop when the element has matched with the some criteria. Drop while start after element matches a criteria. Yeah. So I think some examples I should show. So here what this does, long count rand, what this variable will store, stream dot generate will generate match dot random numbers. Out of them we are limiting them to 100. So dot filter of n greater than zero point 0.1, just the elements which are greater than zero point 0.1 we are considering, and we are counting those number of the elements which are greater than zero point 0.1. So it will count the random numbers larger than zero point 0.1 values. We can find the largest and smallest values by using the method max and min. So yeah, previously everyone are asking, how to, instead like Python, can we use max and min? Yeah, here by using this max and min methods you can use. By if you convert any collection to string, you can convert the collection to string and just say max of, and max method takes some method how to compare. If the list is the elements of string, then you say string colon colon compare to. If they are elements of integers or doubles, then if doubles, you can say double colon colon compare to. So they will compare the those double values and find the max value. So it will give the max dot random, uh, maximum value of the random integers. Requires a comparison function. The max method takes a method, comparison method. Okay, what happens if the stream is empty? If the stream is empty, then what happens if we don't have any numbers in the stream? If we are filtering, we are generating a stream of some random numbers and applying some condition. After applying this some condition, what if your stream is empty? But if you apply some max or min function on that empty stream, then we have to store the return value in optional, some optional. And this will discuss in the later. Week 9 is about optional. Okay. Stream nothing. So streams are nothing but you can convert a collection to a stream by using methods dot stream, and you can filter them. You can iterate over those collection. You can do what, like some, whatever the normal process you do by using iteration, you can do that by using the stream. Just filter them or map them to some function, or find the maximum value or min value of that stream, or count the numbers based on some criteria you can do by using the streams. Okay, just you have to, this is like easy only, but this like week 8 and week 9 are continuation. Week 8 of streams is continuation of week 9. Just understand the streams part first, then you can go to the week 9. Okay, basically in the streams we use the lambda expression extensively, right? We use the, instead of writing the methods everywhere, you are using the lambda expressions. And yeah, these are methods only, you need to, in the streams you need to know what a method does here, how to generate the stream of numbers by using the stream dot generate. Stream dot iterate will generate the stream of dependent values based on the method whichever we give. And then you can convert arrays to stream, you can convert list to stream, and you, the methods, whatever the methods that we have seen on the streams, filter, map, count, max, min, all this method, drop while, take while. Yeah, just take some example in the practice assignment question and understand how, just see it's whether it is clear or not. If it is not clear, we can discuss in the next you can ask in the next session also. Okay, before that I want you to see, if not, yeah, it won't be clear to you even if I explain. Just okay, just you can go through the practice assignment and graded assignment question. Already deadline is over, right? If you have any doubt in graded or practice assignment question, we'll do in the next session also. Okay, then after discussing only we will do week 9. Okay, as week 9 deadline is also there before that. Yeah. Okay, any doubts you have now?
I like stream is like basically it is what we do in Python also, na?
Yeah, it's similar to your Python. Yeah, it's similar.
Text.
Declarative, yes. Yeah,
Yes.
it allows us to program in declarative way.
Okay.
The lambda expression, that is also kind of
Uh,
a decl- not declarative, but it makes us to code easy, right? Like in the Python we can pass functions as an argument to another function. By using lambda expressions we can do that in Java. Okay, that allows some kind of lazy easiness in Java, using lambda expressions and strings, this thing. Okay, yeah, please go through that, the contents, and ask me if you have doubts in the next session. Yeah, if without going, yeah, through this, yeah, it will be good if you go and if you ask me some doubt. Without, yeah, it will be monotonous if I just explain. Just go